Steel is highly resistant to shaping when it's cold, and for that reason it is generally rolled whilst it's hot. To make sure the steel is at the correct temperature for rolling, it is fed into a furnace. Here it travels through several temperature control zones until it's at the correct temperature and ready for rolling. Whatever the product, the principles of hot rolling are the same. Steel is squeezed between rolls until the final thickness and shape are achieved. To do this, the rolls must exert forces of tens of millions of newtons, equivalent to a weight of thousands of tons. The rolls, therefore, run in massive bearings, mounted in housings of enormous strength and driven by powerful electric motors. These are known as mill stands. The layout of a rolling mill can vary from a simple single-stand mill to several stands positioned either side by side or in a line. The mill rolls themselves can either be plain for flat products such as strip, used for products such as cladding, or profiled for sections, beams and columns for use in construction. Mill stands have various roll arrangements depending on the product being rolled. The simplest arrangement is a 2-high stand, used mainly for long products such as sections. For light sections and bars, 3-high stands are sometimes used, with the steel passing one way through the bottom gap and back through the top gap. 4-high stands have 2 work rolls in contact with the steel, supported by larger backup rolls to prevent distortion caused by the rolling face. These give greater accuracy for rolling flat products, such as plate. Universal beam mills include stands with both horizontal and vertical rolls bearing on the steel simultaneously. Rolling processes are computer-controlled and monitored up to 50 times per second. Despite the huge scale of some mills, accuracy to plus or minus 50 microns can be measured. The rolled steel is then cooled in a way appropriate to its end use and prepared for further processing or dispatch.